everybody. Today we will discuss the effect of the substrate on the addition reaction. We know that the addition reaction can be classified into three different type of category: electrophilic addition reaction, nucleophilic addition reaction, and free radical addition. Usually, the electrophilic addition reaction occurs in multiple bonded compound. So it is electron rich in character. So any substituent which enhances the electron in the organic compound will accelerate the electrophilic addition reaction. So electron donating substituent naturally accelerate the electrophilic addition reaction, and the degree of increasing the number of the degree of the substitution, the electrophilic addition reaction also increases. In nucleophilic addition reaction, we know that nucleophile are electron rich in character. So, in order to attack the nucleophile on a multiple bonded organic compound, we have to reduce the electron density in organic compound. So, the electron withdrawing group will enhances the nucleophilic addition reaction. In free radical addition reaction, we know that the free radical are electron deficient species. So, as the electron density in the multiple bond increases, the rate of a reaction is also increases. Naturally, the free radical addition reaction, the radical is generated in the first step, initiation step, and that radical is involved in the propagation step. Okay. Now, see the example. In the first example is the ethylene. If the reaction occurs, if a addition reaction occur by using an electrophile H+, the final product is an alkane. So if we are substituting one of the hydrogen by methyl group, the rate of a reaction is enhanced by 2 into 10 to the power 6. So if you are substituting a methyl group, the electron density in the multiple bond increases. So that's why the rate of a reaction is also increases. So in the third example, we are substituting the hydrogen by OCH3 group. So the rate of a reaction is again increased. See here in this reaction, the speed of the rate is 5 into 10 to the power 14, and we know that OCH3 is considered as an electron donating group. But even then, the oxygen which is directly connected to the multiple bond is electron withdrawing in character. But the lone pair of electron present in the oxygen assist the electron density in the alkene. So the rate of a reaction is also increases in this reaction. Now we are moving into the orientation of the hydration. In the electrophilic addition reaction, the electrophile H+ is added in a less substituted carbon. This rule is known as Markovnikov rule, and see this example. In a alkene, the specialty of the alkene is the one of the carbon atom which is doubly bonded to the carbon atom is attached to 2 methyl group, and the other doubly bonded carbon atom is attached to 1 methyl group and 1 hydrogen. If we use an electrophile H+, so the electrophile attack the least hindered side of the carbon. So we will get a more stable carbocation. Whereas if we attack in the more substituted position, so we will get a less stable carbocation. That's why according to the Markovnikov rule, the electrophile must added in a less hindered side. So we will get more stable carbocation. And now we are moving into the addition in a conjugated system. If our substrate is a conjugated system and that conjugated system is attached to a any function group, we have two different type of the addition, 1,2 and 1,4 addition. If our nucleophile is a And this type of the conjugate addition occurs in nucleophilic addition reaction. So if our nucleophile is a strong nucleophile, then addition is according to 1:2 addition. And if the nucleophile is a weaker nucleophile, then the addition occurs in 1:4 addition. Example is the addition in alpha beta unsaturated carbonyl compound. See this example. So in which our nucleophile is HOO minus and the substrate is a multiple bonded compound which is attached to an electron withdrawing carbonyl compound. So at first the nucleophile attack the less hindered position, and after that a carbanion is generated, and this carbanion is assisted by the oxygen atom and to form a epoxide, and the reaction mostly occurs in alpha beta unsaturated ketone aldehyde and even sulfones. And here if the nucleophile HOOH is a weaker base, that's why a 1:4 addition occurs. So if the 1:4 addition occurs, we get an conjugated system. Okay, so pi d-log the conjugated system is occurs here, and this conjugated system is assisted by the internal attack of a carbanion and to form an epoxide ring. Usually there is no epoxide formation will occur. So in nucleophilic addition reaction only epoxide ring will occur in conjugated system. Okay. Now we are moving into another important reaction, that is Michael addition. So Michael addition means in Michael addition there is a Michael donor and acceptor is there. Michael donor means any conjugated system, any conjugate addition, there is a nucleophile which is formed by the which is a conjugate base, and it is added to an unsaturated carbonyl compound, that is a Michael acceptor. So see this example. At first an base pick out one of the hydrogen in an Michael donor and we have a carbanion. So the speciality of the carbanion is that this hydrogen is attached to this carbon atom which is connected to the hydrogen. Blue color is the hydrogen, and hydrogen is attached to a carbon atom, and that carbon atom is substituted by the two most electron withdrawing group. So these two hydrogen are most acidic in character. So a base can, even a weak base can easily pick out that hydrogen and to form a carbocation, and this carbocation is stabilized by the electron withdrawing group. So that is the speciality of the Michael donor. Now this carbanion is conjugated with a carbonyl pi electron in the carbonyl group. So enolation will occurs here. Then this carbanion is added to a Michael acceptor. So speciality of the Michael acceptor is that an electron multiple bonded compound is attached to an electron withdrawing group here. So the most the donor and acceptor is connected to an electron withdrawing group, then this Michael donor is added to Michael acceptor. So this is the product, and there is a negative charge occurs in the oxygen, and after the addition if you add any proton donating substance, here they are used ethanol as the substituent, so hydrogen is added, and after that tautomerization will occur and we will get a Michael product. So this is the Michael addition. I hope that you understood the concept. Thank you.